Hello, welcome to AP Calculus Lecture 5.5b. And in this lecture, we're going to go over logarithmic differentiation, and we'll be working some problems from page 354. All right, so we'll call this logarithmic differentiation is just differentiation where the variable is an exponent. All right, so we haven't done that, and we call that logarithmic differentiation. So for example, let's find y prime of y is equal to x to the x. All right, so we've got an exponent variable. Y prime does not equal x times x to the x minus 1. All right, the power rule does not work here. Right, so don't do that. And if you're on a multiple choice test, something like that will almost always be one of the answers. Okay, so let's go over the steps of logarithmic differentiation. So first, you're going to take the natural log of both sides and simplify. So we might simplify using, let's say, the power of logs. Step 2, we're going to differentiate implicitly All right, so implicit differentiation, we did that in section 2.5 and 2.6, you might remember, with respect to x. All right, or whatever the dependent variable is. Sometimes it's t, whatever, All right, and then 3, we're going to solve the equation for dy dx and substitute f of x for each y. I'll show you how we do this. So we're just getting the whole equation in terms of x. Okay, so the rest of this lecture will be just examples of doing this logarithmic differentiation. All right, so here we go. So our first example is we're going to go ahead and work that problem, y is equal to x to the x. So we want to find dy dx. Right? Find the derivative with respect to x, or y prime, however you want to talk. Whatever you want to call it. Okay, so the first step is to take the natural log of both sides. So natural log of y is equal to the natural log of x to the x. As long as you do it to both sides, that's totally legal algebraically. All right, and now we are going to simplify. So we've got natural log of y is equal to, what can I do with that exponent? I can bring it out front as a coefficient, natural log x to the x. And that's why we took the natural log, because we want to get that exponent down if we can. All right, so now I'm going to differentiate both sides of the equation with respect to x. So that's what d over dx means. It means it's a verb. Take the derivative with respect to x. Okay, so natural log of y, the derivative of that is 1 over y, but then that's not an x, is it? It's a y, so we have dy dx. All right, remember, the derivative of y with respect to x is dy dx. All right, and I shouldn't have written that again. Sorry about that. We brought that down. So it's x natural log of x. So this is a product rule. First times the derivative of the second plus the second times the derivative of the first. Well, the first is x. The derivative of the natural log of x is 1 over x plus the natural log of x, and the derivative of x is 1. So let's clean this up. I have 1 over y dy dx is equal to x times 1 over x, it's just 1, plus the natural log of x. Now I need to get, I'm solving for dy dx, so I need to have that all by itself. So let's multiply both sides of the equation by y. So that's going to eliminate the 1 over y here, so we'd have dy dx is equal to y times 1 plus the natural log of x. Our last step is to just take that y and put it in terms of x. Well, we know what y is equal to. It's equal to x to the x. So dy dx is equal to x to the x times 1 plus the natural log of x. And that is the derivative with respect to x. So there you go. All right, let's do one that's got a little trig in it. So let's find y prime. If y is equal to sine x to the cosine x power. Okay, so we're going to take the natural log of both sides. So we have the natural log of y is equal to the natural log of sine x to the cosine x power. All right. So now I'm going to use the properties of logs to bring that exponent cosine x out front. So we'd have the natural log of y is equal to cosine x times the natural log of sine x. All right. So now we've got it simplified. I'm going to take the derivative with respect to x of both sides. So this is the implicit differentiation. So the derivative with respect to x of the natural log of y is 1 over y dy dx. And this is the way it's going to be every time. Okay, that left side, you're going to be doing that every time. And this is a product rule. Cosine x times the natural log of sine x. So it's the first, cosine x, times the derivative of the second, 1 over sine x. So 1 over the blop, 1 over sine x, times the derivative of the blop, times the derivative of sine x is cosine x. So that's the first times the derivative of the second, plus the second natural log of sine x, times the derivative of the first, cosine x. Well, that's times negative sine x. Derivative of cosine is minus sine. So let's clean this up a little bit. We have 1 over y dy dx is equal to, we would have cosine squared x over sine x, right? Cosine times cosine, cosine squared. And then we've got a negative there, so minus, and let's pull this sine x out front, minus sine x natural log of sine x. Okay, let's multiply both sides by y in order to get rid of this 1 over y on the left. So that's going to be y times cosine squared x over sine x minus sine x natural log of sine x and then finally we're going to substitute for y. We know that y is just equal to sine x to the cosine x power. So that's sine x to the cosine x power times this monstrosity here, cosine squared x over sine x minus sine x natural log of sine x. All right. So there you go. Not pretty, but that is the answer. The back of the book might try to get a common denominator by multiplying this term by sine x over sine x, then you put them together, but I just really don't think that that's necessary. The test is multiple choice for this section, so you will just have to try to match the multiple choice answer, and on those answers I don't go crazy with the algebraic simplification like they do in the back of the book. All right, so let's do a couple more examples. We're going to do example 34 on page 354. So here we have y is equal to 3 to the 2t over t. Okay, so let's go ahead and take the natural log of both sides. So the natural log of y is equal to the natural log of 3 to the 2t over t. All right, so I'm going to simplify using the properties of logs. So this is division, so I can have natural log of 3 to the 2t minus the natural log of t. And rewrite it like that. Get rid of that fraction. Now I can bring the 2t out front. So natural log of y is equal to 2t natural log 3 minus the natural log of t. I've got it where I can now differentiate with respect to t. So that would be 1 over y dy dt is equal to, now look at that, 2t natural log 3. What's the derivative of that with respect to t? Well, the derivative of 5t with respect to t would just be 5, right? It's just the coefficient. Well, we have a t in the middle of two constants, 2 and natural log 3. So when you take the derivative of that, the t just goes away. It's to the first power. And you would have 2 times natural log 3. So don't let the way that's written with the t in the middle confuse you. If we wrote it like 2 times natural log of 3 times t, it would be pretty easy to see that the derivative is 2 natural log 3, right? Because that's the way we take the derivative of 5t, right? So the t just falls off. So I've had students that be confusing just because it looks different. And then minus the derivative of natural log t is 1 over t. So let's multiply both sides by y. And then our final step is we want to substitute for y in terms of t, which we just go back to the original equation and have 3 to the 2t over t times 2 natural log 3 minus 1 over t. And that is on the test. That's the answer that I would have as a multiple choice option. The back of the book might multiply this by this constant by t over t, and then put them together. And to me, that just makes things harder, and it's just really not necessary. So I think this is simple enough. So let's do one more example. So we're going to do number 32. So that one we have y is equal to x times 7 to the minus 3x. And so we are going to take the natural log of both sides. All right, and now we'll use the properties of logs to split these two up. Natural log of x plus its multiplication, the natural log of 7 to the minus 3x. And now I can bring that minus 3x out front. Okay, and finally, we can take the derivative with respect to x. So that's going to be 1 over y dy dx. See how it's like that every time? Derivative of the natural log of x is 1 over x. And just like in the last one, you have a 3 and a natural log 7. Those are just constants. So the x will drop out since it's to the first power. So minus 3 natural log 7. Multiply both sides by y. You'll have dy dx is equal to y times 1 over x minus 3 natural log 7. Dy dx is equal to, substituting for y, by going back to the original equation, x times 7 to the minus 3x times 1 over x minus 3 natural log 7. Now this is the answer that would be on my test as one of the multiple choice. However, the back of the book will just make the whole thing more difficult. So they would multiply this term by x over x. So that's just a clever version of 1. So that you would have x times 7 to the minus 3x times 1 over x minus 3x natural log 7 over x. Now you can put these two fractions together. So you'd have 1 minus 3x natural log 7 over x, because they both have the same denominator. And now that x would cancel and that x would cancel. So you'd have 7 to the minus 3x times 1 minus 3x natural log 7. So that's what you would see in the back of the book. That isn't, I would not make you go that far on my test. Right, on my test, this would be perfectly fine. I just want you to substitute back in terms of x for that y. But if you're doing your homework or trying to match the back of the book, this is the technique that they use. I do think that it makes things, we're getting out of the realm of calculus when they do that, and they make things unnecessarily difficult with all of the simplification. So your homework It's going to be on page 354, 29, 30, 31, 33, 35, 45, 46, and 47. All right, and you know, in terms of the back of the book, do the best you can to try to get there. You can watch the homework solutions to see how I would do it, but you know, try to match the back of the book as best you can on the odd ones. All right, that'll do it for this lecture, and I will talk to you on the next one.